So guys, आज की live stream start. So guys, let's start today's live stream in which I am telling you about a routine an array by D, counterclockwise or left, and it's an Array DSA part 47 which we are covering in today's video. And who are covering new in my live stream, so please like, share and subscribe. So now let's start today's video. So now let's start. Now it has been given me an array of integers ARR of size n, and our task is to rotate the array elements to the left by D positions. Okay, so now please highlight these things, okay, which I am telling you. Okay, now D and then N and then rotate. Now it has been given me one example also. Here given an integers array, okay, in which he wrote down 1 2 3 4 5 6, and then here he given one integer by the name of D in which he wrote down 2, and the output is coming 3 4 5 6 1 2, because after first left rotation ARR means our ARR integer array becomes 2 3 4 5 6 1, and after the second rotation of ARR integer array becomes 3 4 5 6 1 2. Okay, so if you see the second example, here we get one integer array by the name of ARR square bracket in which he written down 1 2 3, and then here we get one integer by the name of D in which he written down 4. The output is coming 2 3 1, because the array is rotated as follows, because after first left rotation ARR integer array 2 3 1, and then after second left rotation of ARR integer array is called 3 1 2, and then after third left rotation ARR integer array 1 2 3, and after fourth left rotation ARR 2 3 1. Okay, now in today's video I told you about to rotate 1 by 1 0 and multiply by D time and 0 1 space. Then I told you about a better approach using temporary arrays 0 and time and 0 and space. Then I told you about the expected approach. We using the juggling algorithm 0 and time and 0 1 space. Then we use expected approach 2 using the reversal algorithm 0 and time and 0 1 space. Naive approach, rotate 1 by 1 0 and multiply by D time and 0 1 space. In each iteration, shift the elements by one position to the left in a circular fashion. Okay, the first element becomes the last. Perform this operation D times to rotate the elements, okay, to the left by D positions. Okay, so I hope you understand till here. So now it has been given me one illustrations. Okay, now if let us take one here given integer array in which it written down 1 2 3 4 5 6, and then here given integer by the name of D in which it written 2. First step, because it rotate to left by one position, then here it created one integer array by the name of ARR in which it written down 2 3 4 5 6 1, and then it give me the one second step also in which he rotate again to left by one position, okay, in which he wrote down integer array in which he wrote down 3 4 5 6 1 2, because its rotation is done 2 times, so the array becomes array integer ARR square bracket 3 4 5 6 1 2. Okay, now it has been given me a one code also of C++, so let's run this code. So the output will become 3 4 5 6 1 2. Let me show you. So let's open the Replit, because in the Replit we are running all the codes from the starting, like who are my viewers, that all the people know that. So let's open my C++ file. So now it is taking a loading, so now paste it. So now save. Okay, so now let's come on this. There is some numbers are coming, so that's why it has been given me an error. So remove all the numbers and fix the code. So then I will be press the enter. So now it will be start to debug the code. Okay, now it is taking a loading. Okay, little bit it is taking a loading, then I will be show you how it will be run. Okay, so now it is taking a little bit time. Okay, it is depend on your net. Okay, if your net will be fast, so then it will be run fastly. Okay, so now paste, save, run. So now let's see the output. Now here you can see it will, let's see the output. So here you can 3 4 5 6 1 2. There was C plus program to left rotate the array by d positions by rotating one element at a time. In the 8 till 9 line here I define a function to left rotate array by d positions, and then in the 12th line here I repeat the rotation d times, and till 14 till 32 line here I left rotate the array by one position. Okay. Now time complexity is 0, and the outer loop runs d times, and within each iteration the inner loop shifts all n elements of the array by one position, resulting in total of n multiplied by d operation. Alloxeries phrase 0 1. Better approach. Using temporary array 0 in time and 0 in space, this problem can be solved using the below idea. The idea is to use a temporary array of size n, where n is the length of the original array. If we left rotate the array by d position, the last n minus d elements will be at the front and the first d elements will be at the end. First, copy the last n minus d elements of original array into the first n minus d positions of temporary array. Then, copy the first d elements of the original array to the end of the temporary array. Then finally copy all the elements of temporary array back into the original array. Okay, so let's run this code, okay, which it has been given me. Okay, so it gives you the same output, but here we are using the different method. Okay, so now it take a little bit time. I'm just using this code to AI assistant to remove these numbers like 41, 40, 39, 38, 37, 36, 35, like these type of numbers. Okay, it depends on your net. If your net will be fast, so then it will be run fastly. Okay, so now here you can see it. Now let's run this code. So now let's explain you this code. In this code, there's one C plus program to left rotate the array by d position during temporary array. In the 9 till 10 line here there is one function to rotate vector. Then in 13 line here I handle case when d greater than n. And in the 16 line here I am storing rotated version of array, and then 19 till 20 line here I copy last n minus d elements to the front of temp. And in 23 till 24 line here I copy the first d elements to the back of temp, and then in 27 till 43 line here I am copying the elements of temp in array to get the final rotated vector. Okay, so now time complexity is 0n as we are visiting each element only twice. Alloxery space 0n as we are using an additional temporary array. Now expected approach 1, using a juggling algorithm 0 in time and 0 in space. The idea is to use juggling algorithm which is based on rotating elements in cycles. Each cycle is independent and represents a group of elements that will shift among themselves during the rotation. If the starting index of a cycle is I, the next elements of the cycle can be found at indices I plus d modules n, I plus 2d modules n, I plus 3d modules n, and so on till we return to the original index I. So for any index I, we know that after rotation, the element that will occupy this position is ARR I plus d modules n constantly for every index. In the cycle, we will place all the element that should be in that position after rotation is completed. Please refer to juggling algorithm for array rotation to know more about the implementation. So I hope you enjoyed today's video in which I told you about how to rotate an array by t counterclockwise or left. So I hope you enjoyed today's video. If you enjoy, so please like this today's live stream I mean. So if you enjoyed today's Array Dsa part 47 live stream, so please like this video, like this live stream, share and subscribe, and you don't get to all the notification mail also. So let's meet you in the Array Dsa part 48. So now this will last live stream in that week, so I will meet you on Tuesday. Okay, so now let's meet you in Tuesday. So now for today, good. And please, one more thing I want to tell you, please go and access and bookmark my Array Dsa playlist. Okay, go and access it, go and fastly and access it. So now, anyways, so now for today, good. Bye.